talk about solving right triangles. And first, a quick review. The trigonometric ratios are the ratios of the lengths of two sides of a right triangle. So when we're dealing with sine, cosine, and tangent, those are our trigonometric functions, or at least three of them. Or trigonometric ratios, excuse me, or at least three of them. And so just a reminder, sine compares the leg length and the hypotenuse. We remember sine by saying so it's opposite over the length of the hypotenuse. Ca means cosine is equal to the adjacent side length over the hypotenuse. And then tangent is equal to the opposite side length over the adjacent side. Okay, and so remembering those, it allows us to then think about some angle measures. Now these ratios right here help you to find side lengths. It compares lengths of legs. What we're going to do is talk about how to find lengths of it, or angle measures. Okay, the inverse trig ratios are the inverse of the trig ratios used to find angle measures. So for instance, if I didn't know angle A, okay, so let's say I have angle A here, trace it. This is the opposite of A. This is the adjacent to A, and this is the hypotenuse. Okay, so in triangle ABC, measure of angle, the measure of this actual angle, the actual degree measure, would be equal to the inverse sine, and notice we say inverse sine by using sine -1, the inverse sine of the side opposite A over the hypotenuse. Well, the side opposite A is BC over the hypotenuse, or AB. So if we knew those lengths, we could take the inverse sine of those lengths, the comparison of those lengths, and we'd be able to find the angle measure. Okay? Measure of angle A also could be listed as cosine, the inverse cosine. The inverse cosine is the adjacent to A over the hypotenuse. And so once again, we're dealing with the same ratios, adjacent, AC, over hypotenuse, AB. So the same ratios that we use in our previous are sine, cosine, and tangent here. And then the inverse tangent of angle A, we'd have the opposite of A over the adjacent of A, or opposite BC over adjacent AC. Okay, so let's see how we actually would apply this here. All right, using a calculator, knowing A and B are acute angles, use a calculator to approximate each measure and round it to the nearest tenth. So the way we do this equation-wise is we look at sine A equals 12/17. Now if you were to think of an equation like 4x equals 12, well, we would do the inverse operation to solve for x. We divide both sides by 4. Dividing is the inverse of multiplying by 4, like they're doing up here. And so that inverse cancels out, and you're left with 3. Well, same thing applies here if you want to think of it that way. To get A by itself, I have to take the inverse of sine. And the way we do the inverse of sine, you usually don't see this in a book. You don't see, we actually say inverse sine of both sides. Okay, but really, that's one way you can think about it. Those cancel, I'm left with A. Okay, the inverse sine of 12/17. Now if you find the inverse sine button on your calculator, it's usually second sine. So you find the shift key or the second key and push it, and that gives you the inverse sine. And then put in 12/7, you'd find that the measure of angle A is equal to 44.9 degrees if we round it to the nearest tenth here. Okay, so hopefully you'll try this one on your own, but if I want to get B by itself, I've got to take the inverse sine of 0.24. So we move sine over and it becomes inverse sine. Okay, so I now have B equals, well, the inverse sine of 0.24 is 13.9 degrees. Same thing with cosine. If I want to move it over, I've got to take the inverse cosine. Okay, and the inverse cosine of 3/8 is equal to A. So when we do that, A is equal to 68.0 degrees. And the last one, if I'm going to get tangent over here and get B alone, I have to take the inverse tangent of 1.4. That tells me that B is equal to 54.5 degrees. So you're finding angle measures. The inverse, or the inverses are used to find angles. Okay, sine, cosine, and tangent are used to find sides. So the inverses find the angles, the normal find the sides. Okay, so now if I'm going to solve a right triangle, in order to solve a right triangle, you need to find all side lengths and all angle measures. And you have bags of tricks to do that. You know a bunch of things. You know Pythagorean theorem, you know special right triangles, you know the triangle angle sum theorem, you know sine, cosine, tangent. Okay, we have to find 6 different things. We have to find angle A, angle B, angle C, and that's the measure of each of those. And we have to find the length AB, the length AC, and the length BC. Okay? Now some of these they give us, like angle C. Angle C is 90. We know that. They tell us AC. AC is 7. BC is 4. We have to find AB and angle A and measure of angle B. Well, notice if I know 2 sides of a triangle, I can find the third by using the Pythagorean theorem. Okay, and the side opposite angle A we actually call little a. The side opposite B we call little b. Side opposite C we call little c. The angles are uppercase. The side lengths are lowercase. So what I know using the Pythagorean theorem is a squared plus b squared equals c squared. And I know that a squared is 4 squared and b squared is 7 squared, and that equals c squared. Or 16 plus 49 equals c squared. C squared is 65, so c is equal to the square root of 65. We ignore the negative part because it's a length there. Okay, so c is equal to root 65, says round to the nearest tenth, so let's actually call that 8.1. Now one caution, if you're going to find angle measures using your side lengths, you don't want to use the one you rounded. So try to use 7 and 4 to find your angle measures. Okay, so let's say I want to find angle A here. Well, angle A, side A is opposite A. Side B is the adjacent to A. This is an A here. Okay, and then we obviously have our hypotenuse over here, which we're not going to use because we rounded it. So if I want to find angle A, I could use opposite and adjacent, and opposite and adjacent is tangent. So I could say the tangent of angle A is equal to the opposite of A over the adjacent of A. Or find A by moving tangent over and take the inverse tangent of 4/7. And we find that A is equal to 29.7 degrees, and that's rounded to the nearest tenth. Now if I know 2 angles of a triangle, I can find the third because all the angles add up to 180. Or better yet, if one of those angles is 90, the other 2 have to be complementary. So 29.7 plus B, measure of angle B, has to equal 90, right? And so we move that over, we find out the measure of angle B when we subtract 29.7 from both sides is 60.3. And we have now solved the triangle. All right. Let's go ahead and try another one. Okay, let's solve this triangle. Notice we have some different pieces here this time. Okay. First, I look at it and I want to find, once again, I want to find my angle measures. So measure of angle A, measure of angle B. Well, that is a weird looking angle symbol. Measure of angle C. And we always know if it's a right triangle that C is 90. They show us that. Okay, we also want to find, the length of AB, the length of AC, and the length of BC. And they actually give us AB is 20, and they give us AC is 12. Okay, so we can find the third side length by, once again, using the Pythagorean theorem. All right, we know that this is A, this is C, this is B. Okay, and so we have A squared plus B squared equals C squared. But this time C is our hypotenuse, and we know that. Okay, we could plug that in, and I'm just going to show this part of it, and then I'm going to talk to you about something else. Okay, plus A squared. Now you can finish solving that if you want. However, and I just set it up so you could do that. But the other thing to remember is, if you remember what Pythagorean triples are, like 3, 4, 5, okay, this is a 3, 4, 5 triangle here. 12 is 4 times 3. Okay, 20 is 4 times 5. So that means this side has to be multiplied by 4 as well. This is a 3 and a 5. This is a 4 by 4, right? So now we have 3, 4, 5 triangle, all being multiplied by 4. So this is 16. So one way to solve that is using Pythagorean triples. The other way is just finishing up the Pythagorean theorem. Okay, it's the quicker way to use the triples. Okay, but if you don't know the triples, we would get A squared equals 400 minus 144 is 256. And so then A is equal to the square root of 256, or A equals 16. Same thing, right? There, we've got that. We also need to find some angle measures. So again, since you know all three sides are perfect side lengths, you can use any of your trig functions you want. So I'm going to go ahead and use sine this time. Okay, the sine of, and I'll find angle A. Angle A is equal to the opposite of A over the hypotenuse. Okay, so the opposite of A is 16 over the hypotenuse is 20. To find A, we're going to move that over. We're going to get A is equal to the inverse sine of 16/20. And so A, in this case, is equal to, what we got here? Like 53.1 degrees. Okay, and so now if we want to go ahead and find B, we know that measure of angle A plus measure of angle B equals 90. Angle A is 53.1 plus B equals 90. Therefore, B would have to equal 36.9. All right, and so we now have solved the triangle. Okay, let's look at one more quick one, triangle like that. I realize that it's kind of getting cumbersome, but I just want to point out when you're finding your measure of your angles, so measure of angle A, measure of angle B, measure of angle C here. We know angle C, obviously, because we're dealing with right triangles, is 90. And then we find AB, AC, and BC. Okay, and they give us one side length. In this case, AB is 14. All right, and they give us angle A is 32. Well, if they give you two angles, remember you can just jump right into the triangle angle sum. Angle A and angle B have to add up to 90 degrees. So don't get in the habit of just automatically going, oh, I've got to use inverse, okay, because it doesn't always happen. Okay, so in this case, the measure of angle B would be 90 minus 32, or 58 degrees there. All right, so we have 58. Now, given that we have perfect angle measures there, they are whole number angle measures, you can use any of your angles to find your other two sides. Okay, and so I'm going to just use angle B here. So I've used angle A for everything else. Okay, and so if I want to go through that, I could say, well, this is the opposite of B, and this is the hypotenuse, and here's my adjacent. Okay, so if I want to find the, for instance, BC, which is little a, right? I would know that the cosine of B, or the cosine of 58, is going to be equal to the opposite, or the adjacent side, so angle, or side A, over the hypotenuse, 14. You got to go 14 times cosine 58 equals A. Now notice I didn't use inverse cosine because I'm not finding angle measures. I'm finding side length. All right. And so cosine, or 14 cosine 58 gives me, I believe A is 7.41. Oh, and we're going to the nearest tenth, 7.4. Okay, and so that is side BC, 7.4. And you can label it on your picture also if you want. Now you can find the last side using the Pythagorean theorem, or just use opposite over hypotenuse. That seems easier. So opposite over hypotenuse is the sine of 58 is equal to opposite of B, which we're calling little b, over the hypotenuse. So we get 14 sine 58 is equal to B. So B is equal to 14 sine 58, which is 11.9. And there we got it. All right. So hopefully you get pretty quick to work through. All right, one last thing, a quick story problem. Find the distance across the river if the angle of elevation to the top of the 10-foot tall pump house on the other opposite side of the river is 8 degrees. So let's switch up colors here. So we have this river. Okay. We have this pump house, which is right on the edge of the river. Okay. There's a pump in it to pump water of some sort. And then we have this angle of elevation of someone standing right here on one side of the river, looking up to the pump house, and you have an 8-degree angle of elevation from a horizontal. Okay, so probably a better picture for you would just be seeing this triangle here. Okay, so here's our right triangle. So I'm going to go ahead and blow up that triangle. So here's the triangle I'm dealing with. Okay, we have 8 degrees. This pump house stands 10 foot tall. This is an angle of elevation because you're going from a horizontal line. So that's the key there. From your horizontal, you're elevating to the top of the pump house. Okay, probably not the best picture ever. What we want to know is how far is it across the river. So X there, right? All right. So if I'm going X and 10 in relation to my 8, this would be my adjacent to 8, and this would be the opposite of 8. Okay, or side opposite 8, our angle of 8 degrees and adjacent of 8 degrees. So we have the tangent of 8 is equal to the opposite, and we're SOHCAHTOA, opposite over adjacent. So 10 over X. Now please don't let that 8 mislead you. If you want to call it A, you could put A there. I don't want the 8 to mess you up, but we're dealing with this angle. Okay? And so when I multiply this, I get X tan 8 equals 10 to get rid of the fraction first, and then we have to move that tan 8 over by dividing. So x is equal to 10 over tan 8. And 10 over tan 8 ends up giving me 71.2 feet. So my picture is obviously not to scale there. Okay. Well, I hope that helps out. I think that's it. Yep. Good lucky.